So when I take a look at one of these word problems like this, the first thing I like to do is figure out exactly what am I trying to answer, because then that also tells me about the variables. All right, so in this case, notice it's asking us how many of each type of vehicle could transport all 31 people to the ski area in one trip. So the question is really one of how many of each type of vehicle. So then that tells me my variables. What's the first type of vehicle?
A van.
The van, yeah. So I'm going to go ahead and start by defining that I'll let V represent the number of vans. And the other type of vehicle is the sedans. Okay? And so I'm going to make S represent the number of sedans. Now you notice I did not use X and Y. That's on purpose. Because otherwise we get halfway through the problem and we forget what meant what. So whenever possible, use variables that actually mean something relevant to the problem. It makes your life easier and it makes your work more reliable. Plus it at least breaks up the monotony of X's and Y's. Alright, so now that we know that we're dealing with vans and sedans, I need to write some equations. Now, how many equations will I need to write in this case? Well, how many variables am I solving for? 2. And so, how many equations will I need? 2. Whichever number of variables I am solving for, that's the number of equations that I will need. Alright, so then, as I take a look down this, the first thing that jumps out to me is all this information about how many people each type of vehicle can actually carry. How many they can all seat. Because like we got this information here about the vans can seat 7, sedans can seat 5. And so we can use that to then start figuring some stuff out. So the vans each seat 7 people. So that means I can write an equation of 7V. Now notice that's 7 times V.
Plus V.
Because it's 7 per van. 7 people per van. Anytime you can phrase it in terms of the word per, it's multiplication. So I know to multiply 7 times V. Plus, how many can I carry in the sedans?
5S.
5. So that means, yeah, it's going to be 5S. And that needs to equal the total number we have to carry. Now, what's the total number of people we have to transport here?
31.
It is 31. Now, in there, sometimes it's tempting to say the 26 because the very first number we are told up there is that there's 26 members of a youth group that are going. But remember, we also have the chaperones, who are also our drivers here. And so they have to also be in the cars on the way up. So yes, we're using the 31 number. All right, so that's one equation. I need one more equation, though. What is that other equation going to be?
Well, since, like...
Yeah,
Oh.
because there's going to be 5 chaperones, and each chaperone is driving a van or a sedan, that means that the number of vans plus the number of sedans is going to equal 5. All right, I have a system of equations. Now that we have our system, you solve it the same way that we've been solving all these systems. So go ahead and solve it from here, please. All right, so when we work this all the way through, you should end up finding that they're going to end up needing to use 3 vans and 2 of the sedans in order to have no seats unoccupied, which is the sort of thing they'd probably be looking for because the vans probably get a lot worse gas mileage than the sedans do, so we're wanting to maximize the number of sedans we can take up there and not have to waste that gas. Things like that would come into play on this. All right, so working this problem, let's start again by figuring out what is the actual question I'm answering. Okay, so look in there, look for the question. Of course, we've got the question mark at the end that tells us look toward the end. It says, how many of each type of shirt should you buy? So that tells us to focus in on the types of shirts. My answer is going to be how many shirts. Well, what are the types of shirts in this?
Yeah, rugby shirts, polo shirts, and t-shirts.
Yeah, exactly. It's all of these up here. And so those are going to be my three variables. And I'm just going to go ahead and use T for t-shirts, P for the polo shirts, and R for the rugby shirts. All right. And so knowing that, I can now go ahead and start writing some equations. How many equations am I going to expect?
Three.
Three, absolutely. And that's because we got three variables, of course. All right. So for my first equation, well, I'm just going to start reading through this thing and take it as I find it. So the first number I see there is the $6,000. I'm going to use that then in an equation. So for $6,000, that one is about money. So basically what I want to do then is go and look for any other numbers that are about money. And so then I have the 12, the 24, and the 36. So basically all of those numbers are about money, so all those are going to combine into a single equation. Notice the 12 there. That's $12 per t-shirt. I said per. What does that tell you it's going to look like? Yep, it's multiplication. So we're going to go 12t. Plus, and I'm just going to go down the line, grab the other ones. It's $24 per polo shirt. And then it is $36 per rugby shirt. And that's how much it costs us to get each of those. And so then we want to stay within that $6,000. And we're going to go ahead and say equals here because we're going to assume that they want to utilize their entire budget and get the most they can out of this whole thing. All right, so I got that. Now back to my original question here. The next number that I haven't yet used is the 200. Okay, so I'm going to write an equation that involves the 200. So I'm going to have something where it equals 200 like this. But what's going to be on the left side here? So, exactly. All we actually need to do is just add up all the different types of shirts. So T plus P plus R will equal 200. Sometimes those throw us off because we don't have other numbers associated with them. So if that one kind of threw you off a little bit, be aware of it. All right, now back to our problem. Let's hear. What haven't I used yet? Well, we want to have twice as many rugby shirts as polo shirts. And this is actually a piece that sometimes will throw us off. Because the question comes up, is it going to be R equals 2P, or is it going to be P equals 2R? And if you're not sure, do yourself a favor here. Plug in a number really quick. Like, let's say we're going to check that first, let's see here. We want twice as many rugby shirts. So normally what I see is I see 2R. Twice as many rugby shirts would equal P. Just grab a number. Like, let's say we plugged in 5 for R. 2 times 5 would equal 10. So we'd have more polo shirts than rugby shirts. Is that what we want?
No.
No, that's not what we want. So that tells me it's not 2R, it's the 2P. So we're actually going to be writing that is our equation. R equals 2P. Now, I took a moment on that because I actually see that same mistake come up a lot. And if we don't stop and think it through, I will see a lot of mistakes on it. So, we now know that R equals 2P. Oh, by the way, if you're curious, why do we get so many mistakes? Look at the wording up here. As we're reading this, we see twice, so the number 2 is in our head, and then we see rugby shirts. It's putting it into order of 2R in our brains. So that's what ends up throwing us off. All right, anyway, back to this. We got 3 equations with 3 variables. We can solve this then. So I don't need any more equations. Everything else then is all just about the math. Okay, but how do I deal with that? Because that last equation is a little bit awkward compared to some of the things we've seen before, right? So what can we do? So a few different possibilities of things you can do. And then we're going to pick one and I'm going to go through it that way. One option is that we could take our top 2 equations here and we could eliminate a variable. But if we do that, which variable would we have to eliminate? T, yes. Because notice this equation already has the T eliminated, so I'd have to eliminate the T if I'm going to just add them together like that. Okay? But that can sometimes be a little awkward. So another possibility. Well, you might choose to format this last equation more like what we're used to seeing, so you might say subtract that 2p from both sides, and you could rewrite it like that. Maybe that would leave you feeling a little bit more comfortable about it. Or, there's actually one more method, and I want to go through this last method just to show you that we can use this and that this is possible. Because when solving systems of three equations, it tends to be all about the elimination method. But we can actually still use the properties of substitution with it. I can take what r equals, and I can substitute that in for r in the other two equations. And so I'm going to go ahead and do it that way, just to kind of show what that would do and how we could handle it. So let's plug in.
Smart.
And then once we've plugged it in, notice in both of those equations, I have p appearing multiple times. So I can go ahead and combine those like terms, and then it's going to look like what we're used to working with. And then you can solve it from there.